All right. So here we have a parabola. Parabola goes on forever, so we can add the arrowheads if we like. And what we just discussed, you can see that this parabola doesn't pass the horizontal line test, so its inverse won't pass a vertical line test. But the question is asking, how could we restrict the domain so that it does? So if we took out a whiteout pen, if I just looked at numbers less than 0, I erased all this, would it pass the vertical line test? No, that wouldn't be enough. But if I erased some more, how much would I have to erase? I'd have to erase until I got to the vertex. And if I erased until I got to the vertex, then that would create something that passes the horizontal line test. And then when we do the reflection, our new graph would pass the vertical line test. So anytime you have a parabola, it's basically that key point is the vertex. And if you did anything in front of the vertex, or as another option, if we erased this part, it would pass the horizontal line test again. So how do we do that? Well, the first one that we looked at, was when we just did this part. I'll label that half in blue. The equation for that is still y equals x minus 1 squared plus 3, but we're only looking at the blue graph when x is bigger than or equal to 1. So if we restrict the domain by saying x is bigger than or equal to 1, then we're going to get something that passes the horizontal line test. And that inverse is going to be a function. Now, when we solve for the inverse in these ones, and I'm going to solve for the inverse here by switching x and y, and I'm going to switch x and y right away this time. And then get the y minus 1 by itself so I can square root both sides. Add 1 to both sides. And this time I'm going to put the plus 1 on the right. Now the question is, for my first one, when I do x is bigger than or equal to 1, which of those two equations will be my inverse? Will it be the positive one, or will it be the negative one?
Sorry for the interruption. Just a reminder, we still have quite a few students that have not yet picked up their report cards / registration forms for the next coming up school year. If you have not done so, please come to the office immediately after the bell today. Thank you. And also, there is a very important brief meeting in the football.
So, what do we have here? What I've done is I just took some of my points on my blue graph and I switched them. So instead of the vertex, I have 3, 1. Instead of this point at 2, 4, I'd have 4, 2. And we can see that I have that square root graph. Can you see that that square root graph has not been flipped over? In fact, maybe I want to color code this for later on. I'm going to put this one in blue too, because it matches up with that blue part. Can you see that it has not been flipped over the x-axis? So as far as which equation I'm going to use, it's going to have to be the inverse, the positive one, x minus 3 plus 1. According to our transformations, does that look right? Does it look like a parabola that has been moved 3 to the right and up 1? I mean, not a parabola, a square root graph that's been moved 3 to the right and up 1. Yes. Now, if we wanted to do a second restriction, can you see that you could have done the other half of our parabola? That would still be the same equation, but the domain now is x is less than 1. You could put an equal sign with it too. That would be fine. That would restrict the domain as well, so that it stays. And the equation for that one will be the inverse. Well, now if I started switching x and y's, I would get that part. Does it make sense that that inverse has been flipped down first, but still moved 3 to the right and up 1? So we've written the equation of the inverse for both of them, and we've restricted the domain once for the blue graph and once for the green graph. So the ones you can do for this are 10 and 12.